Alright, let's go ahead and give a run through. This is number 10 out of section 10.2, and I chose this question because it basically gives us an overview of the whole entire problem. When we look at these guys, our biggest thing we want to think about here is that we want to make sure we realize that this is a multi-step question. This one really encompasses the whole deal. So ultimately, even though our long-term goal is to determine whether we're going to reject the null hypothesis or fail to reject the null hypothesis, when we start off, we want to identify what we know. Okay, so what we know for sure is that we know that alpha, I'm not very good at drawing alpha. Alpha is equal to 0.05. That's our critical value there, that critical evidence value or test value. We know that we want to see that the medicine relieves pain in more than 377 seconds. So that's our actual sample. Our sample is, excuse me, no it's not. That is actually our mean. And so we know that our actual population mean is 377. We keep reading along. We know that our sample size, how many people we have, is 77 patients. And then it says that out of those 77 patients, when we tested them, we found out that our sample mean was actually 383. And we come back through, and our population standard deviation is going to be 21. Alright, so with that situation here, we've got these pieces identified. Oh, and our last piece is that we basically have this claim. We want to see if there's enough evidence to reject the null hypothesis or to fail to reject the null hypothesis based upon this idea that our mean is greater than 377. Alright, so with that said, what I would highly recommend is that we use the tutor key. And what the tutor key does for us is it kind of walks us through until you become more proficient. You still get credit for the question if you get it right, but it kind of walks you through. Now obviously when you take the quiz, or when you're actually certifying or taking a test, you're not going to have this option to be able to do the tutor, but right here it'll help you practice. You can take the notes and then have those notes available, so when this question pops up on a test or on your certify, you have it as a reference. So our first question is let's see, what is our null hypothesis? So pull up our keypad, open that guy up. Come on, keypad. Put that away. Let's see maybe what's going on here. Keypad is not wanting to work. Let's try that. There we go. So our mean, in this particular case, our mean or our original claim is that we are going to be less than or equal to our 377. Alright, and that is because we're basically, our claim, which is our alternative hypothesis, is that we're going to be greater. So our null hypothesis is always opposite of our claim. We check it, we move on. Now it asks us for our null hypothesis. We got the mean, and our null hypothesis is our claim. So, excuse me, our alternative hypothesis, our H of A, is our claim. It's what we're trying to show here. It's what we're trying to look at. So in this particular case, our claim is that we are greater than 377. Okay, and so moving through the steps now. So remember, you would be kind of taking detailed notes here to make sure you had what you needed. Originally, remember, we went back here and we talked about the fact that we identified these data values before we got going. Let's put that away. And so we've already identified that we believe that our sample mean is 383. So we type in our sample mean. We know that our mean is 377. We know that our population standard deviation is 21. And we know that our sample size is 77, and that's our variable. It's just plugging it in from this critical value here. Alright, so this guy is kind of cool because it checks us and tells us, hey, yeah, you got them in the right spots. But now it says, can you plug that into the calculator and get the right answer? So we pull up our graphing calculator, and we're going to plug those in. So, what I would recommend is that I would take on, when I'm doing this, I take on the denominator first. So I would go ahead and take 21 and divide it by the second square root of, 77? And so that gives us my denominator. So I'm not gonna, you wouldn't normally write this out. I'm gonna show you how to use your calculator, dot dot dot. And so now I'd come back up here to my calculator and I'd say, okay, well, I'm gonna go ahead and do the numerator now. So I got 383 minus 377. I pressed enter, so now I've got my numerator, which is 6. But I don't really need to write this down because I can use my calculator. So what I'll do is I'll say divided by, and then what that does is it takes my actual 6 right there, and it says, okay, take that answer and divide it by. Well, divide it by what's in the bottom. Well, I can just arrow up to what is in the bottom. Once I'm on top of it, I press enter and that pulls it down. So now essentially what I have is I have 6, the answer, divided by this previous thing. I press enter and I find out in this particular case that my z-score is 2.507. But it says round your answer to 2 decimal places because z-scores are 2 decimal places, and I get 2.51. So that's going to be my z-score that I'm going to test. So what does that mean that that's my z-score that I'm going to test? Well, if we think about this as far as on a normal curve, what we're trying to say here is that we have this is the mean, that's right smack in the middle, and then this is 1 standard deviation and 2 standard deviations and 3 standard deviations, and we're sitting out here someplace around 2.51. So somewhere between, we got this test value of 2.51 that's chilling, and what our claim is that we're going to land in that zone right there. That's our claim. That's what's going on here, is that we're going to be greater than that. Alright, so we can go ahead. The cool thing about this software is that we go ahead and we just type in what we think the answer is, so 2.51, and cool, good job. So we got our answer. So now comes the question of well, what does that mean as far as my graph? Okay, well, let's go back to what I just did a minute ago. On the normal curve, remember that we're looking for, we talked about more than 377. Well, 377 has a corresponding z-value of 2.51. So remember how you can standardize a test score? The 377 can be standardized into a z-score here. So there's my 377 right there. We want to know if it's going to be greater. So we come over here, and that's going to be our p-value. That's going to be that guy right there. So we test out our hypothesis and we say, alright, good deal. So now we have this p-value is going to be greater than or equal to 2.51. And I know a lot of you are going, well, that says more than. It doesn't say more than or equal to or greater than or equal to. But when we're going and we're thinking about this on the curve, we're going to have that landing point. It's going to have to be from a starting point moving up. So just kind of keep that in mind. Alright, so now our job is to go and find this value, the probability, the p-value of this guy being greater than 2.51. So we pull out our table up. Okay, we go to our standard normal curve table, and let's take a look at the first one. So what this table is saying is it's saying that in this case right here, I'm going to take from 0, so from the mean, to my biggest z-score. So my biggest z-score being 3.49. So that's from basically 0 to 3.49. So like on the curve, that means I'm looking at from right here to right there. Okay? So then let's see. Oops, I gotta turn that thing off. So that was the first one. So what we did from negative infinity to 0. Oh, my bad. That's what we did first. Excuse me. That was what we had first. Was negative infinity to z. All right. So now we're going to go and try the negative infinity to negative z. Now, the reason that I know that this is the right one for me is because what I actually have to do is that all of these numbers in the table are really data values that are talking about from being from. Let me hit pause in that thought for a second. Give me 1 second to investigate something. Alright, I'm glad I hit pause there because I was about to say something dumb. So let me go back and touch base on this. So if you have the PDF that I printed out for you, or that I gave to you guys inside of the materials for the course, what the PDF in there does is it is only the area to the left. So it is only, when you look up an area there, it is only the area to the left. And so what that basically means is that's negative infinity to positive infinity. Now, what this table does for us is we have several different situations. We have 0 to z. So 0 to z, so the first one, that would mean that I would have, oops, sorry, that would mean that I'd basically be going from, I don't know why, there we goes. That means I would be basically going from 0 to whatever z-score I had right here. And that would be that area right there. So that's not really what we're looking for. The second one would be negative infinity to z. So that would be the area from negative infinity to whatever z-score you had, like maybe right there, and that would be that area in that particular case. The next one, sorry about that. Let's get that out of the way. So the next one would be negative infinity to negative z, and that's the one that we're looking for, because negative infinity to negative z means that we're basically going from the smallest value down here up to your negative z, and I was actually off. This z would actually be right over here. So so what we're looking for is probably going to be this guy. It's going to be the easiest way for me to kind of keep everybody on a consistent path here, and that, you know, we're going to go ahead and use this. Even though our z value is up here in the positive area, we're going to use the negative to help us reference, and then I'll tie it in how that makes sense. So for us, what we're going to do is that we had this test value. Pull this out of the way real quick. So we had this test value of 2.51, right? So what we're going to do is we're going to go find negative 2.51. So remember, on our normal distribution curve, if we did negative 2.51, that's going to be exactly the same as 2.51 up there. So the area under the curve here will be equal to the area under the curve right there. So we'll go ahead and we'll come over here and we'll find that negative 2.51. So negative 2.5, cruise across, and looks like I'm going to have to pull this just a little bit, and we've got our 1 right there. So in that particular case, we're looking at a z value of, for the 2.51, we're looking at a z value of 0.06, I believe it was. Tables, and pull this guy down. Come across a little bit. Yep. So I'm sorry, 0.006. So 0.0060. And so that's going to be my actual test value, even though that's the area right here. Sorry, 0.0060. This is a symmetrical graph, so that's going to be also the area over here, the area above. Now, if we want to use our table also, we could use it from z to infinity. So from z to infinity, that's going to basically be from our z-score greater. So that's going to be from that z-score and greater. So if we go to 2.51, let's see what happens. 2.51, and it's slightly different. Oh, no, there it is right there. So 2.51 would be 0.0060, and that once again is going to be the area above, because that's going from z to infinity. Slightly confusing. You know, I'm more of a traditional guy. I like to use that standard normal distribution table. You know, and so go back and think about my videos. I've shown you on how to use those if as needed. So anywho, what we got is this. Bottom line comes back to, we have a test value of 0.0060. Test that out and it says good work. So from there, what does that mean for us? Well, that means that we're ready to go ahead and make a decision. And our decision is that this test value that we have, this p-value, is equal to 0.00. Sorry about that. Our p-value is equal to 0.0060. Our alpha is equal to 0.05. So we have a couple of situations right here. We have, if our p-value is less than or equal to our alpha, Well, that looks like our scenario, right? Because 0.0060 is less than 0.05. So if that's the case, then we will reject the null hypothesis. And if rejecting the null hypothesis, all that really means for us is it means that it opens up the door for us to move forward, to ask more questions, to say, okay, well, maybe there is something going on in this particular scenario with this significance level from the new data that we've collected. So, you know, we had this historical data that we collected where the mean was 377, but then we sampled 77 more people and found out that their mean was 383. So rejecting the null hypothesis doesn't prove anything. It just opens up the scenario for us to say, well, maybe we should go and look a little bit deeper. Either way, that's how we work our way through being able to do our hypothesis testing for the population mean when it's known. Good work, and use this video as needed.